Hello, Year 9. Today will be the last lesson of the half term, and here's the work folder for it. I'd recommend you have your periodic table open, because it will always be useful in this topic. So view, rotate view clockwise, there we go. Now, this sheet and this sheet here, 3.3, both of them are extra information on this topic. So if my descriptions aren't good enough, or I've missed something out and you are a bit confused still, have a look at those two worksheets. Here is an extension question. So when I mentioned that there's an extension question to do, this is the extension question. Here is the distillation worksheet, and here is the chromatography worksheet. So I will ask you to complete these during the lesson, but for now let's go straight into the PowerPoint. So we definitely need to know what all of these words mean. They're probably so it's kind of like a recap from Key Stage 3, right? These are the foundations, and we will use these words a lot, and we need to be able to parrot the definition off word for word perfect, really, because if we don't understand what these words mean, it stops us from being able to build up into something that's more difficult. So I think the most difficult three are actually the bottom ones, because you don't use them as often as element, mixture, or compound. So on the next slide are the answers, so I'd like to have a go at telling me what you think they mean, or in your mind you can write it down, it's up to you. Think what is the definition of each word, and then once you've done that, you can unpause the video and go on to the next slide and see what the textbook definition is. Okay, so let's go on to the next slide. Here they are. We need to know what all of these words mean, and we need to be absolutely sure that we know them. Again, I can't stress enough how fundamental these words are for the topic. Okay, compounds. When we talked before, because again this is kind of like a recap lesson of Key Stage 3, so we're moving everything back up to speed and recapping everything very quickly that you've probably learned over a few Key Stage 3 topics. A compound, we say that it is when two or more different elements are chemically combined. What we actually mean by something being chemically combined or bonded together is they are sharing electrons. Sharing or giving electrons, that is when a reaction happens. And that is pretty much what chemistry is. Chemistry is the study of the movement of electrons, okay? So here's methane, here's sodium chloride. The one on the left is a covalent compound, the one on the right is an ionic compound, and we will learn what these mean and specifically how they bond together. So we're taking the fundamentals of, oh well, this is a compound because it's bonded, and now we're looking at actually how do they bond on a fundamental level. Here's another one, glucose. Now, you cannot separate a compound back into an element unless you use a chemical reaction to do that. Okay, the bonds are very strong. You can't just pull them apart. So let's have a go at naming these two. What I'd like you to do is I'd like you to look at the key here, pause the video, and try and come up with the answer. So, hopefully you've had a go. On the left there, we have got an oxygen here. So I'll get my pen out. We have got an oxygen there, and a hydrogen, and a hydrogen. Well, we should know that this is H2O from the formula, but what is H2O? If you said it's dihydrogen monoxide, you would get that's right, but really we call this one water. So let's have a look at the one on the right. Well, that's carbon there. This is an oxygen, and this is an oxygen. Well, that's CO2, and this is called carbon dioxide. So, yeah. Little recap there. Hopefully that jogs your memory a little bit. Now, when we get back to school, we will do these experiments. Just to remind you of what they are, but we've done them all in Key Stage 3. We're going to recap filtration, evaporation, distillation, and chromatography, which in Key Stage 3 was 4 different lessons. Now that we've done them before, and it's a bit of a recap, we can actually cover them in this one lesson. Now, What you'll need to do is you'll need to go to the extra information sheet, have a read through it, so that you understand the process that happens in all 4 of these separation techniques. But I'm going to very quickly go over filtration and evaporation on this slide. Okay, filtration, which is this one. You have got an insoluble solid. Insoluble. You've got an insoluble solid, and that means it does not dissolve, and a liquid. We usually use the example of sand and water. Okay. You have got some filter paper, and what happens is this insoluble solid, these particles are too big to fit through the tiny holes in the filter paper. But the water particles or the liquid particles are small enough to fit through, so pass through the filter paper. So what you are left with in the bottom is you are left with the liquid. This could be a pure liquid or it could be a solution. This could be sand, water and salt, but because the soluble solid is dissolved, the soluble solids will pass through with the liquid. So this method only separates something that is insoluble. Okay. In the bottom there you are left with a solution, and in the top you will be left with the residue, which will just in this case be the sand. So the experiment that we would do for this we would be trying to separate salt from rock salt. So you would grind up your rock salt and you would dissolve it in water. What would happen is the salt would dissolve in this water, but the rocks would not. So then you would separate out the rocks and you'd be left with salty water here. And that is a solution of salt and water because the salt dissolved. Then what we would do is we would take it over to the evaporation experiment. Now, evaporation separates a soluble solid from a liquid. So in this case, we've got salt water. We've got a salt water solution. What happens is you heat this, the water will boil at 100 degrees or slightly over 100 degrees, and then evaporate. And you will be left behind with some salt crystals in the bottom. Okay, so this is one way to separate salt and water, or anything that has been dissolved inside a liquid. Now, a typical exam question that they love to ask. If you have rock salt, how can you get a pure dry salt from the rock salt? And remember, the rock salt is rocks plus salt. Okay. Now, I've gone through the experiment there. You need to add water and then use the 2 separation techniques to separate it. Remember, there is the extra information on the other worksheet, the 3.31. And if you are stuck at answering this question, look at these pointers. Why do you need filtration? Okay. If you're still unsure, follow the success criteria. Then if you're still stuck, why do we use this? And then follow the success criteria. Okay. So try and get as in-depth of an answer as you can on how to get some pure salt from rock salt. If you'd like to do the extension exam question, if you found that really easy, have a go at that too, please. So let's move on to chromatography. Chromatography is in a classroom is used to separate colors or inks. Okay, they are dissolved inks. Okay, that is what you do it in a classroom. The general definition is it separates a mixture of soluble solvent. It separates a mixture of soluble solids. Okay, so if I have 2 or 3 different solids dissolved in a liquid, in a solvent, right, I can use chromatography to separate them. We use dyes or inks because we can see the difference between the inks, but you can do it with stuff you can't see. You just have to use something to be able to see it. For example, you could use a UV light to see some things that are not visible in normal light. So, what's chromatography for? You separate soluble solids. Okay. Now, here, important things about chromatography. This line, that black line, this one, is in pencil. Why? Because pencil is not soluble in water. It is insoluble. So that line will stay there throughout the whole experiment and will not move. That is your start line or your baseline. That is where you measure the movement from. Another point is that you can see that they have put a big ink dot on the line. But notice this black line here is the water line. Now your water line has to be below your ink. If you dip the ink inside the water, let's say I put a dot here instead, what happens is the ink just runs out into the water and doesn't give you any valid results. Okay? But because this person has set it up correctly, what happens is that the paper sort of draws in the water because the paper is very dry. Okay? The water sort of travels up the paper like this, and as it travels up the paper, the water molecules go past the ink and dissolve little bits of ink. The more soluble inks travel further up. So in this example, yellow is much more soluble than this red colour. The more soluble inks will travel further up with the solvent. The less soluble inks will travel less far. If something doesn't move, it's insoluble. Okay, last one that we're recapping is distillation. This is if you have a solution of two liquids. So in this case, you've got water and ethanol. We use this one because it's the easiest to separate. Ethanol has a boiling point of 78 degrees, while water has a boiling point of 100, so you don't have to heat it very hot. The biggest process in industry we use this for is called fractional distillation, and we use it to separate the crude oil we get from the ground into different things like petrol or wax, etc. So, you have got a mixture of two different liquids in here, water and ethanol. You're using the fact that water and ethanol have different boiling points. So what happens is you heat this solution here until one of the liquids starts to boil. You can figure out which one starts to boil because you've got a thermometer up here reading the temperature. Because it boils at 78 degrees centigrade, you can go and get a table or go and Google which liquid boils at this temperature, and you can figure out which liquid you've got. Then, so here we've got a liquid. Then you've got a gas. So the liquid boils into a gas. So in this case, it's the ethanol that goes first. Then that gas passes down here. As it passes down here, it gets cooled because you've got cold water going around a sleeve that's around the outside of this experiment. It's like putting a drink in a bucket of ice water, okay? It will cool your drink down, but the ice water doesn't get in, okay? So you've got a sleeve of cold water going around the outside and going out. As this gets cooled, it goes back into a liquid again. So you've gone from a liquid here, you've evaporated into a gas, and then you condense back into a liquid, and then you drip into this container. When you have finished, okay, and you will know that you have finished because this temperature will increase again. This will stay at 78 degrees until all of the ethanol is boiled off. After all of the ethanol has boiled off, the temperature will go up. You know that you've finished. Then at the end you'll have some pure ethanol here and some pure water here. And then you have separated the two liquids that were mixed together. Now, just if you'd like to, you can do this blind and see what you can remember. The distillation worksheet has an unlabeled diagram on it. Okay, have a go at that, or have a go at labeling this one. So pause it, have a go. If you are not sure, you can come back and we'll give you the answers. Okay, let's continue. Here are the answers. This is a round bottomed flask. That is the only addition I'm going to put on. Round, R-O-U-N-D, bottom. This is pronounced as Liebig condenser. And everything else I think you understand. Remember, we draw Bunsen burners as little arrows like that. Okay, now the next one. Which letters, so I should say which box contains mixtures? So write the letters down. So again, pause the video, have a go, and then we'll come back. Right, I assume you've had a go and you've unpaused the video. Now remember, a compound is something that has two different elements joined together, but a mixture is something that can be separated. So this, right, this is a compound because it only contains this molecule. You see, they're all identical, so this has to be a pure compound. Part B, this one is a mixture. You've got the element sodium and the element chlorine mixed together. Because there are gaps in between, you could separate them back out again if you wanted to. C, this is also a mixture. You've got the compound sodium chloride and the compound water mixed together. D, this is a compound. This is methane, but this is also an identical molecule, so these are both the same, so this is a pure compound. Here we have got a mixture for E. You've got nitrogen mixed with oxygen. This is also a mixture for F. Carbon dioxide is mixed with carbon monoxide. They are very, very similar, but because this molecule is different to this molecule, they are different compounds. Because you've got a mixture of different compounds or different elements, that is a mixture. Again, this is a mixture. I think you're getting the hang of it by now. Okay, 3 different molecules there. And for H, this is also a mixture because you've got methane, okay, and ethane. They look similar, but they are different. Sorry, that's ethene. Now I'd like to have a go at the chromatography worksheet. And then we are done. You don't have to do the flashcards unless you would like to. But that is today's lesson. So please complete those worksheets, email them to me, and then enjoy half term because that is the last lesson from us for this half term.